Hi, everyone. Welcome to Life Edge, because life just doesn't have to be mediocre. I'm Rick Zanotti, and I'm joined today by my good friend and co-host, Dr. Susan Nash. Hey, Susan, how are you?
I'm really excited about our guest today. We have Ellen Scott Williams, who is a technical storyteller, and I'm just really looking forward to her insights.
A storyteller and an engineer, which is a really interesting combo.
Yeah.
Me too. Here we go.
This show is sponsored by Relay Corporation. Digital learning development, media development, corporate video, management consulting, and more. Visit us at www.relate.com. Thanks.
And we are back in our center position of power. Susan, do the honors.
Okay. Well, I'm really glad to have the opportunity to introduce Ellen Scott Williams. I met Ellen in conjunction with a very fascinating conference that we had in Houston that dealt with difficult technical concepts. And as an engineer, I was really struck by how clearly Ellen got her message across. So Ellen, do you want to tell us a little bit about your background and what got you interested in narratives?
My experience has ranged from a large international oilfield services company, Schlumberger, all the way up to some startup technology companies in the industry recently. And right now, I'm currently an independent consultant. The global pandemic has had a lot of impacts on everyone in their own unique ways. And for me, it actually disrupted a 5-month international travel trip that my husband and I were doing as an extended honeymoon. So that started on January 1st. We were forced to come home right in mid-March as everything shut down, and just trying to reach out to my network and figure out what sort of consulting opportunities might be out there. So again, I really appreciate the opportunity to be on this show, talk about my experience, talk about my expertise as another way to reconnect with the industry.
That sounds great.
So I'm curious, where did you get trapped?
It was in Morocco, actually. So it could have been worse. We could have been in Tanzania. We had just hiked Mount Kilimanjaro and spent a few lovely days on the coast of Tanzania. And we had been in Morocco for 2 days before they announced that they were suspending all international flights. And we figured we'd better try to get on the last available flight to the U.S., which we were lucky enough to have done.
Wow.
That sounds pretty exciting. And you did Kilimanjaro too. Engineer, risk taker. You're fun.
Yeah, that was probably one of the hardest things I've ever done. We happened to have terrible weather on some day, just complete whiteout conditions.
Oh, gosh.
Couldn't see anything, and our fingers and faces were frozen, but we made it to the top.
And it's about 4 or 5 day hike, right?
We actually did the longest version, which is 8 days, where you kind of take your time through the rainforest and up through the moorlands and really get your bearings, because you scale over 12,000 feet in elevation. So it's good to have those acclimation days.
That's amazing. That's great. Well, you know what? You're not going to do that every day, so congratulations.
Thank you. Thank you.
So
but yeah, going back to your storyteller comment, I think I'll jump to the slideshow and talk about the importance of technical storytelling. And I didn't really know what it was or call it this at the time, but I actually learned a really valuable lesson about this in college. If you go to the next slide, then I was part of an Engineers Without Borders student chapter while I was in college. And we were, for those who aren't familiar with Engineers Without Borders, it's similar to Doctors Without Borders. It's just as the name suggests, it's a team of engineers that go to developing countries and try to develop projects that will help that way of life, engineering projects. So for example, for our group, we went to a tiny little village called Huamansanya, Peru, to improve their biomass cooking stoves. So you can see on the right there, we've got a little map dot on Google Maps where that village is located. It's in the northern part of Peru. You can see on the left a beautiful picture of the Andes. It's just at the foothills of the Andes. But since it's on the western side, it's actually quite arid there, almost a desert climate. But in case you aren't aware, across the developing world, there are many people who are still just cooking on open trench fires or open cooking or open campfires, essentially. And as you can imagine, this has some pretty important health and environmental impacts, because when we were visiting Huamansanya, we would go into the kitchen when the women, because it was usually women cooking, your eyes just immediately tear up when you've got smoke inside your kitchen, inside these four walls, and the walls are covered in soot. Those women are breathing in all of those particles, and then on the environmental side, they are spending a lot of their days walking around, finding wood, finding biomass that they can burn for their 3 meals a day. So it's a pretty big challenge that, of course, as Princeton engineers, we thought we are going to use our engineering power to save the world and save this project. So if you go to the next slide there, on the left, you can see us in our little makeshift workshop. Once we got down to Huamansanya, we were taking notes on the wall, sourcing local materials, building a prototype stove. And then on the right, you can see one of the finished products in one of the villagers' homes. And so a couple of things to point out. Our friend Brian there is just finishing the top of the stove, but there'll be a metal plate on top of it. So again, keeping that smoke inside, using a metal plate to heat up so that you're not having to put your pots directly on an open fire. You can see that metal chimney there to filter all that smoke out. And then that little white box that you see in front, that's the combustion chamber. And so we had done some work studying this throughout the school year before we went down to Peru in the summer to understand how to properly design a combustion chamber so that we're getting the most effective burning and using the least amount of wood necessary to heat up that heating element and cook food. So, sounds like a win-win, right? We're using less wood, we're getting the smoke out of the house, we saved the world, right? Well, I still remember how disappointed we were when we were cooking on our first stove that was first installed. I think it may have been Doña Elena's house, and we're cooking her first meal with her for breakfast, watching to see the excitement on her face, and she looks a little anxious, she looks a little disappointed, and she told us this is taking longer to boil water than it normally did. And we got some other comments like, this is not the way that my mother and grandmother cooked. And right away we learned this lesson that you can't just come in and offer an engineering solution without those soft skills and without really understanding someone's way of life. You can't just come in with the facts and the figures.
Yep.
That is so true. And I
We
saw
just
that
lost her.
also. I've done quite a bit
Susan,
of work for
Susan.
USAID, and I saw something similar to that in Mozambique, where people were unwilling to use the wood that they had collected to boil water, but yet river blindness is a big thing there. So like it was pretty challenging. So did you develop a story to use with Doña Elena?
So unfortunately, we were only there for 4 weeks, and so we built as many stoves as we could, and the next year, the team that went back really worked on this big education campaign to talk about resource uses, to talk about the benefit of the project that we had put in place. So unfortunately, I did not join the next crew. The following summer, I was actually doing an internship for Schlumberger, so getting into the industry. But it was still a very valuable lesson to learn. And now that I'm in the energy industry, I realize that that's a metaphor for this industry too. I mean, you cannot walk into someone's office who has a workflow, even if you have the best new technical product, they won't accept it if you just talk about, here's why it's better, here are the sleek new design, here are the technical figures of merit. That storytelling aspect, explaining the value and explaining how it's going to change someone's workflow and really listening to them and having that back and forth, that's a really important aspect in any technical industry.
Do you have any specific examples of like a challenging workflow or communication issue that you've seen in the past?
Yeah, for sure. So I have spent, I've worked with now 2 startup technology companies in the industry, Fracture ID and Deep Imaging. And so Fracture ID has developed an innovative way to measure rock properties while drilling. And so typically these types of high resolution measurements were only acquired by running a wireline log, so running an extra tool down in the well after it were drilled. And Fracture ID can do it with just a small sensor within the drill bit or the drilling assembly. And so it's a great technology. It can give you high resolution data, but at the same time, that high resolution data doesn't necessarily sell itself, because a lot of oil and gas operators aren't even logging their wells. They're just treating each one like a cookie cutter. And so to try to walk in and say, hey, I've got this cool new tool, that's not enough. You have to describe, here are the valuable data, here are the lessons that it can teach you, and here are some business decisions that you can actually change to either save money or make money.
You know, Ellen, what you're talking about reminds me a lot of a more creative, innovative way of doing change management. It's kind of like that, except it's more innovative. It takes a different approach, which is kind of cool. Susan, are you there, Susan?
Yes, I am here.
I think you need to introduce Ellen to Deepak, who was on the show a couple weeks ago.
Oh, right.
I see a connection.
Yeah.
I did watch that show. That does seem like a very interesting technology.
Yeah, and I can see a connection between what you do and what they're trying to do. Mm-hmm.
Well, the other thing too that I mean, obviously, I'm going to try to hold myself back because I'll talk too much. But I love what you're doing, because with my background in literature and my dissertation on and how narratives affect people, I always talk about the apocalyptic narrative. Well, at any rate, the point is that we're hardwired to be persuaded in different ways, and so some people are going to be persuaded by ethos or the credibility, others by logos, the logic, and the data. And some people are going to go for the emotions, the pathos. And what I'm hearing often is that people go in assuming that every person listens and makes decisions the same as they do, and they have the same priorities, etc. Have you had that experience?
Yeah, and I should say that it is a spectrum, right? I mean, there are some early adopters. If you think about, I'm sure we all have that friend who wants the brand new iPhone as soon as it comes out. There are those early adopters who will buy something or adopt something just for its novelty, as long as the facts line up and the technical credentials are there. But then it's once you get to those later adopters, to some of the laggards, that you really need a convincing argument to get to adopt new technology. So I should say that, yes, it's not always the case that you can't impress someone with a shiny new technical toy that does some really cool things. But yeah, there are a lot of different ways that people make decisions, different things that they value, that are important to them. So that's certainly an aspect to convincing someone to adopt something new or try something new.
Well, and it's fascinating too, because here we are in a world where we were somewhere around 4 or 5 in terms of Maslow's hierarchy of needs, and we're hovering around self-actualization, when suddenly we're back down to 0, or well, there's not 0, but like 1, which is survival needs. And so your story is going to have to change based on people, where they are also in terms of their perceived needs. Can you talk about that a little bit?
Yeah, I guess, do you mean specific to the industry, or you're talking completely?
Just in general, when you do the
broadly?
storytelling.
Mm-hmm. Yeah, so I guess to go back to the stove example, the time that it takes to boil water is sort of number one. First and foremost, I need to feed my family quickly, and the long-term thought about, if I breathe in this smoke 3 times a day, every day, it will shorten my life. You're right, when you have different needs, you're going to think about either the immediate or the long term. And then I guess sort of going to the industry, there are different operators that may be trying to just flip their acreage. Obviously, that's not really possible right now. But there would be operators who were just trying to flip their acreage, so they didn't necessarily care about the long-term health of their oil and gas wells, versus a very large operator who's like, we're in this acreage to stay, we want to maximize the life of it. So yes, understanding someone's needs, understanding where they are in terms of what's most important to them is certainly an aspect that you'll need to address when you figure out what story will resonate with them.
You know, we were talking a little bit pre-show before you came on, Ellen, about selling to engineers, selling to doctors and lawyers. Those are 3 of the toughest sales out there. Engineers want to know everything before they buy. So, for example, if you're a car salesman, an engineer, I've known people who are car salespeople, and the minute the engineer shows up, they would always try to find somebody else to help that person. Nobody wanted to help the engineers, because that meant it was going to be a very long time as the engineer went through every aspect of that car in many cases. Doctors hate change. Engineers don't like change. It's an interesting field, because these are fields that change all the time, and yet they're some of the most least likely to like change. It's just sort of funny. But see, what I see of what you're doing, from what you're saying and some of the examples you're giving, is it's a way to get people to start kind of taking that slight leap forward before taking a big jump. And like you said, some will take a jump quickly, the new iPhone, the new whatever, and others will go, let me wait a couple of years and see how it goes. And so somewhere in between, there's that kind of more normal person who says, I'm gonna think about it, but I'm ready to move. What do I need to do, or how do I adapt? What's the benefit of this? And correct me if I'm wrong, but is that kind of what you're doing in many ways?
Yeah, I would say so, because I think that person is probably very logical, and they will say, I'm not going to wait until everyone's adopted it, but if I can determine that, yes, this is something that can solve a problem for me, then I'm open to it. Yeah. So I guess if we want to look at some more pretty pictures, we could go to slide 9 on the slideshow to sort of illustrate this point. So for those who are not familiar with microseismic data, it is, as the name suggests, very tiny earthquakes that are induced by, or I should say seismicity. I shouldn't put fracturing and earthquakes in the same sentence. They're really, really tiny earthquakes, about the size of me dropping a book off a table. But these are the very small seismicity that's induced by hydraulic fracturing. And this is a highly technical process. It takes geophysicists to model how sound waves move through the earth in order to locate where all of these little microseismic events occur in fracturing. but they have a real benefit to engineers, because the engineers, they're the ones who design these hydraulic fracturing jobs. They're the ones who want to know, how effective was my hydraulic fracturing job? Am I going to get more oil when I do this? What if I change to this? How does the rock break differently? And so what you're looking at here is like a map view of the same well, just over 3 points in time, where you can see I guess it's a little hard to see on this screen, but the first third of this particular frac stage, which is coming out of that little green box that you see in the middle of the well. Again, you're looking map view on top of a horizontal well, and the purple dots occurred at the very beginning of the fracturing stage, and then what the operator did is they dropped some material in the first third to try to plug off some of the preferentially treated fractures, and tried to create new fractures by dropping some balls to sort of plug up what was preferentially taking fluid and sand. And so then that next segment there, that yellow, is where the rock started breaking after they dropped that first amount of what's called diverter material. So that material to try to divert the fluid into different rock, try to break new rock. And you can see that it looks fairly successful. It looks like there's a different azimuth that the fracture created. The dots, the microseismic events, are showing up in different places. That suggests that the frac job did, in fact, create a new fracture network by dropping that diverter. So then the third pane over there on the right, there's some dark brown microseismic events, and those occurred after a second drop of diverter. And what we concluded here was most of those are sort of falling on that same azimuth that was already created by the yellow dots. Maybe that second drop of diverter, that third segment of the stage, was not as effective as the first one. So we were doing this, there's a paper reference on there too, in case at the very bottom, in case you did want to go and look up this paper to learn more about it. But we were doing this in real time, so that after every fracturing stage, we would talk with the client, talk with the person who's spending the money to pump all this material, and say, hey, this is what we're seeing. It suggests that maybe you only need one diverter drop, and that third segment is not as effective as the first two, and you can get away with using less material and still get the same bang for your buck. So this is just kind of an example of using a very highly technical geophysical technology that then speaks to an engineer so that they can make a decision that eventually will save them money. And there are some references in the paper too showing that it also got more gas per foot of lateral than some of the offset wells that did not use this technology and did not try to make changes on the fly. So it was effective both in cutting costs as well as producing more gas per lateral foot.
That's great. And so by seeing the diagrams and seeing the data, especially real time, they were able to actually adapt quickly to that kind of information?
That's exactly right. Yeah. So each fracturing stage is anywhere from a few hours, say 2 to 4 hours. Mm-hmm. And so getting that information, then you can make a decision on your next stage. So you're making a decision within a few hours based on all of these data.
So an instant saving of money. They don't have to put the rocks into, or the balls into an area that probably won't work, and they can see instant results. That's pretty cool.
Yeah, I really liked it too, the way that you used the diagrams and the colors and connected that to the narrative of what's going on, because you get the story across instantly and it's very persuasive. And I like the way that you combine that with the illustrative diagrams.
Thank you.
So I have a question. Okay, so now I've been reading a lot about where investment is going to go the next 18 to 24 months. We know it's not going to go into drilling and completing, at least not at the pace that it has been. And so where are a lot of those dollars going to go? And the argument is that a lot of money and investment is sort of coming from almost angry money, saying that we never want to be in the situation again where we are reliant on a sole source. And countries throughout the world are all having the same conversation. How can we start up manufacturing that guarantees us at least the basics that we need? And it extends also to the oil industry and in all the industries. Do we have local supply? Can we use global networks, global apps, global competencies to assure global survival or local survival? And I was excited by how you could use some of your abilities in some of those solutions.
Yeah, no, you're right. I that's part of why I'm trying to diversify myself and explain that my skill set is applicable to more than just the hydraulic fracturing industry, because I think if we're smart, then we are not going to be investing much money into completions and hydraulic fracturing these days. You may see some wells that need to be drilled just to hold a lease, but they might choose to frack them much later when they know that the oil price will hopefully be higher. I mean, it's going to be higher than negative, hopefully, right? So we may end up seeing that what's called the DUC, or drilled but uncompleted, DUC count, start to really increase. I think one is specific to the oil and gas industry, where the money really might go is on the production side. So understanding how can we shut in these wells so that we're not losing money by overproducing, but still maintain their life and not risk clogging up our downhole pumps or messing up our artificial lift equipment. So I think the production side is going to be pretty important here soon. And then I also think that investors care so much about the environment, the green initiatives, we aren't, as an industry, we aren't going to be able to cut any sort of environmental promises that we've made, right? If we promise that we're going to reduce our methane emissions on our natural gas wells, that can't be one of the things that we cut when we're looking at our budget. You know, that's something that investors have said that they really care about. So that's something I'm interested in figuring out more about as well, is are there aspects of the environmental side, are there new technologies in air quality or reducing water that will really be invested in right now, because we can't go back on those promises. We can shut in our wells, but yeah, we can't go back on those promises.
Though it is funny, Susan, when you're talking about, all the latest and how everybody wants clean this and clean that and green this and green that. Let's not forget all the scams from Solyndra on over the last, 15 years? That so much for green energy, right? There was scam after scam after scam. They all went under and nothing happened. And I think whenever you hear the word green nowadays, there's probably some scam attached to it, because the people calling for it tend to be politicians. Just keep that in mind. And when we talk about the supply chain, there's one word that comes to mind all the time, and that's greed. We went single source out of pure greed, and that's common sense. A lot of people have been criticizing this for 20, 30 years. And now that it happens, they go, oh, this is terrible. Look what... people have been saying that for years. If you go to one single supply chain source, good luck. And look what's happened. It's nothing that anybody didn't predict. It's just that when reality hits, it bites. And that's just, I think, human nature.
That's true, but I will say, though, I don't think the green is necessarily all generated by scammers.
But there's a lot of that.
I think that, for example, in the future, we may see that oil and gas production is primarily used for petrochemicals, et cetera, and we use electric cars. But I was just thinking of one example of a pivot, recently. I was talking to some people that are at Baker Hughes, and in Tulsa they have chemicals. They do oil field chemicals. Well, as you might imagine, there's not a lot of demand for that, and they were like worried about laying people off and furloughing. I mean, everybody's having to do that, but they were able to pivot and make disinfectant and use hydrogen peroxide and ethanol, and then also use electrostatic sprayers, not as a permanent business plan, but saying, okay, we're using our capacity, and now as people start to open up a bit, they're going to have to disinfect to different levels that they did before, hotels, everything. And I thought, okay, you know, we're agile. We can come up. I mean, and so Ellen, you're really agile. You and the teams can come up with solutions. Now the key is to tell that story.
Mm-hmm.
And I guess, you know, kind of going back to my area of expertise, if we go to slide 8 in my slideshow, kind of another interesting sort of parallel to draw here about how we're in a low-cost environment and we want our supply chains closer to us. We want to be able to control our information and not rely on a data processing center somewhere halfway across the world. This is a pretty interesting chart that was published in the Journal of Petroleum Technology, JPT, in October of last year, sort of talking about how we can't just keep hydraulic fracturing and completing our wells in this cookie cutter manner. We have to be gathering data. We have to be learning from it in order to get make the most oil and gas out of our wells that we can. And so what you're looking at here is a pyramid where you've got the highest cost data at the very top. So like fiber optics, which it sounds like you heard a little bit from Deepak about a couple weeks ago, the borehole microseismic, that's the example that I was showing. And I put a little box around that to say that I had some experience with projects there from 2014 to 2016. Most recently, moving down that pyramid, then I worked with deep imaging, which has come up with electromagnetic fluid tracking. So a way to just use electromagnetics set out on the surface to image where the fracturing fluid is going, a little less expensive than the fiber optics and borehole microseismic. So it becomes a little bit more scalable. You're able to do that on more projects, more wells, rather than a permanently installed fiber optic cable, which is very expensive and would be unlikely that you get that on more than one well in a project. But now if we look all the way down at the base of this pyramid, you've got wellhead pressure gauges. And so those are, as the name suggests, nothing fancy, just a gauge that can sit on every wellhead relatively inexpensively and measures pressure. And when I first started presenting this graph and talking about the options for real-time completions, we still understood that the surface, the wellhead pressure gauges, so just taking measurement up at the surface, knowing that our reservoirs are 1 mile to 2 miles below our feet, you weren't necessarily going to get the best data, but they were inexpensive. So they were easy to implement on every single well, but how much data do you really get by trying to infer what's going on downhole from a column of fluid? But what's been really interesting recently is Devon Energy, and there's the paper reference there if anyone wants to go look it up. They have just realized that if you keep that well sealed, meaning you don't perforate it, you don't fracture it, you can use that just newly drilled but uncompleted well and a surface pressure gauge to actually map where your fractures are intersecting that well. So say you've got a well, so here's a horizontal well, and then next door to it, you've got like two or three others. This well can be your monitor well just with surface gauges, very inexpensive diagnostic, and it can tell you when the fractures from this well are intersecting that wellbore. It's a very small pressure change, but it represents where you actually get a fracture tip. It's not inferring, it's not pressure, it's not shear. It is truly the fracture fluid making it to to that well. And so this is pretty groundbreaking, I think, because now you don't have to worry about your fiber optic cable getting to your well on time, your microseismic team not being able to process your data on time. All you've got is just a basic pressure gauge to give you this information, as long as you've got a good data management system to sift through all of that pressure data. So I think this is kind of to bring it back to completions, Susan, talking about what we're all realizing, that we need to be able to control the things that give us the most value. And if we've got all of our surface pressure gauges within our control, we don't need an external vendor, and we're able to get really good data from a low cost, then I think that's where the fracking industry is going eventually, when we start having enough money to frack again.
That's pretty interesting.
That's amazing.
Low tech wins.
That's really interesting. I mean, that's so innovative. I definitely want to look up that paper, because that's just truly creative.
It is, and they've got great just visuals and comparisons to the fiber optic data, the microseismic data. Like, they've validated it with all of those high-end expensive data sets. And it's pretty cool.
That is good. Well, we are at the end of our time. And Ellen, that's been really interesting. And if people want to get a hold of you, what's the best way to do that?
Yeah, please reach out to me on LinkedIn, send a connection, and say that you watch this Life Edge and you want to learn more about technical storytelling or completions, or how I can bring technical storytelling to a completely different part of the industry, or whatever you want to chat about. So yeah, please reach out to me on LinkedIn.
Okay, that's in. We'll put your LinkedIn info below so that people can reach out to you that way. And that was great. That was actually very informative, and interesting solutions and an interesting approach. So
definitely.
We wish you the best, and we owe you a referral. So either Susan, you probably should do it, or I can do it. Whoever, we'll get a hold of Deepak and introduce you. I think that'll be fun.
Oh, definitely. Oh, yeah. I think that would be an interesting introduction, and I think also, I just really am eager to hear your perspective on all sorts of challenges that are coming up in the industry, and the new opportunities, because the industry we know now will be very different in even just a year or 18 months.
Yeah, what Susan means is we'd like you back on the show again to talk about these things.
That's right.
Great. Yeah. Well, once again, thank you so much for having me. It's been a real pleasure.
Oh, pleasure's ours, and thank you, and good luck on your search for doing more good work in the industry. We wish you the best, and if you're watching, Ellen's information will be below, and we'll see you next week on Life Edge. Have a good one, everyone. Bye-bye. Thanks.
Thank you.
You know,